is 2 sine x times cos x. Yeah, I just didn't hit the thing after I zoomed it. Thank you, though, for telling me. Who is the pen clicker? Who is the clicker over there? Better? Okay, so the proof, it actually comes from the formula we looked at yesterday, which was our sine alpha plus beta. And what a double angle means is that the two angles are exactly the same. So I'm going to make this alpha plus alpha. I could have made it beta plus beta, x times x plus x, theta plus theta. I just chose alpha because I kind of like drawing them. You can write whatever you want. And if I simplify inside the brackets, what's alpha plus alpha? 2 alpha. Okay, so that's the same as up here on the left-hand side. Now I'm going to go to the right-hand side. So if we go back to sine alpha plus beta, what's on the other side? Sine alpha cos beta. Whew, that was a little painful. And so this just means that I'm replacing every angle with alpha. So I'm keeping the sine alpha. This is going to become cos alpha. Ooh, cos. I have another cos alpha. And the last term becomes sine alpha. And I'm just going to simplify. I have one sine alpha cos alpha. And I have another sine alpha cos alpha. How many do I have? 2. So there's the proof of why sine 2x is what it is. It just comes from the sum and difference formula. Okay, let's do the same thing for cos. So this time I'm going to start with the proof, and then we'll figure out what the equation is. So give me the right-hand side of cos alpha plus beta. Let's see who's got good memories. Cos alpha. Yes.
Minus cos sine alpha.
Yeah. And so to represent a double angle, I'm just going to use alpha twice. Again, you can use x, theta, y, p, q, beta, gamma, delta. And this just means I'm going to replace everything with theta, or with alpha, so cos alpha minus sine alpha, sine alpha. On the left, I'm just going to simplify in the bracket, so alpha plus alpha, 2 alpha. On the right, I have a multiplication and a subtraction and a multiplication. What do I have to do first? So cos alpha times cos alpha, cos squared alpha. And a sine alpha times itself, sine squared alpha. So there's the formula for cos 2x. It's cos squared x minus sine squared x. Or we can take this and we can play around with it. So you'll notice there's 3 boxes for cos 2x. There's one formula for sine 2x, but 3 of them for cos 2x. So what I'm going to do is go to this box, and I can take out either the sine or the cos squared. Why? Just because we can. So I'm going to leave the right or the left-hand side alone. I'm going to leave that cos 2x and the negative. And all I'm going to do now is use the Pythagorean identity we had before. What does sine squared equal? 1 minus cos squared. So I'm just playing around with identities and just subbing things in. And I can distribute this negative. So minus times 1 is minus 1. And minus cos squared x plus cos squared x. And I can simplify. I have one cos squared x and another cos squared x. How many cos squared x's do I have? 2 cos squared x, and then minus 1. So there's our second formula. Same formula, we've just played around with what it looks like, gotten rid of sine. Or I'm going to go back to the original one up here, and this time instead of taking the sine squared out, I'm going to take the cos squared out. So if I take cos squared out, what is it equal to? Cos squared is equal to 1 minus sine squared. And because there's nothing in front of the brackets, I can just drop them. So I get 1 minus sine squared minus sine squared. In simplifying, I have 1, and then I've got 1 minus sine squared and 2 minus sine squared give me negative 2 minus sine x. And there's our third formula for sine 2x. So just before you write these on your pink card, just want to review that a little bit. One formula for sine 2x. There's nothing we can do to make this look different. I can't swap in the sine or the cos because they're not squared. These are the exact same formula. We've just played around with what they look like. How do you know which one to use? Well, you'll see when we get to the questions, it's pretty obvious which one you're going to use. Take a look at this first one, because what your brain is going to want to do is say, that looks like sine squared plus cos squared, and you're going to want to turn it equal to 1. This is very different from cos squared plus sine squared. Okay, so grab your card. You're going to the back of your second card, or if you're still on one card, squish it in somewhere. We're going to do tan in a second, so you're going to need room for that, but you're going to put your sine 1 formula and then your 1, 2, 3 sine cos formulas. So back of the second card, or if you're still on one card, squish it in there somewhere. Thank you. What did I forget? Oh, it doesn't matter.
Really?
Because they're going to take it apart once we do it. I just needed it stapled so they wouldn't get lost.
Oh my gosh.
That's it. Go redo it.
What to add?
Go redo it. Are these on your formula sheet? I don't know. Let's check. Talbot's saying no. Or maybe yes. They're right under the ones that we did yesterday. You'll notice all of the trig formulas are on the left-hand side of your formula sheet, so they're all together. They're not because we don't use them every day, so those are more the common ones that we use regularly. Honestly, sometimes I have to pull up my formula sheet to remember these. Tan especially, I never remember what tan is. And since we're talking about tan, we could do the same thing. We could prove it using tan alpha plus beta. We're just going to save the time. I'll just tell you what it is. Tan 2x equals 2 tan x divided by 1 minus tan squared x. And you notice it looks kind of similar to the alpha plus beta. It's because that's where it comes from. That is our last trig formula. That is it. Whew. So add that one to the back of your second card, or if you're still on one card, squish it in there somewhere. Is there 19? Is that how many we're up to? It's crazy.
Like counting the ones that we just split.
Yeah. Just go ahead and read the examples because they look very similar to the questions from yesterday. So you'll notice we can do the same kinds of things with these new formulas. We can find exact values, we can prove identities, we can solve equations. Okay, so why do we have these? Because they let us do things we couldn't do beforehand. Okay, so example number 1. So we're given Q3, that's probably important for something. We're given sine of theta. And the first one we want sine 2 theta. Common mistake, people are just going to take this fraction and times by 2. Well, if I times by 2, isn't that sine 2 theta? No, what does it equal if I times by 2? It equals 2 sine theta. And 2 sine theta and sine 2 theta mathematically are very different. So I'm just going to make a note, and you may not want this in your notes, it's up to you. This does not equal just 2 times sine. It doesn't work that way. What does it equal? Well, that's why we have a formula. So your back of the pink card, probably the first formula you wrote down, what does sine 2 theta equal to? And I'm just going to match the variable. So because I have theta on the left, I'm going to throw theta onto the right. Just like yesterday, this is a substitution. So this is going to be a fraction, and this is going to be a fraction, and then we're going to multiply them. Do I have one of those, none of those, 2 of those? So what do I have? Don't everyone speak at once. No, I'll get confused. Do I have both of these? No, which one do I have? Sine theta. What do I not have? Okay, this is exactly like a question from yesterday, which was a question from the first unit. Okay. Ooh.
Sorry for the interruption. Mr. Roadley, please contact the office, please. Mr. Roadley, please contact the office.
Sine is what side over what side? What do I need for cos? Is it a Pythagorean triple, or do I need to do some work? Need to do some work. 1 and 3 is not a Pythagorean triple. So we need to figure out what negative 1 squared plus a squared equals 3 squared. Negative 1 squared, 1. 3 squared, 9. A squared equals? Oh, I'm just still on a squared. You're a step ahead of me. So just a squared equals?
9 minus 1.
Yes, which is? 8. Therefore, a equals? And can we simplify root of 8? This is why we love Pythagorean triples, because that was a lot of work. So a is 2 root 2, h is 3. We need to look at the quadrant to figure out if the sign is positive or negative. Offers negative. Why? Okay, if we look at the cast rule in quadrant 3, cos is negative. Okay, so I'm just going to keep this 2. I'm not freaking out about it. It's just a 2. It's just a coefficient. Just going to hang around in front there. Sine we were given is negative 1/3. Cos we just found is negative 2 root 2 over 3. Little imaginary 1 under the 2. And so we have top times top times top, bottom times bottom times bottom. 2 times negative 1 times negative 2 root 2. So let's just do it in pieces. 2 times negative 1, good, times negative 2. And the root's just going to tag along, so we get 4 root 2. On the bottom, we have 1 times 3 times 3. Can I simplify? Can I reduce? There is sine 2 theta. Okay, so just like yesterday, this is just a straightforward substitute into the formula, simplify, and figure out what the answer is. I'm going to give you about 3 minutes. Find someone who looks really smart and try B together. This is now just a question from last unit. So suggestions. Mika. Do you want to go to the left or do you want to go to the right? Doesn't have the same ring to it. Where'd the ones go? I cancel. Factor. What kind of factoring? But what do we call, what kind of factoring? You can, yes. Common factor, so there's common terms between the two of them. I'm going to take the 2 as well because it's common. What do we do after we factor?
Split and solve.
What do I do with the 2 here? Just divide each side by 2. And this tends to throw people off, and I don't know why. What's 0 divided by 2? Just 0, so the 2 disappears. Okay, unit circle value, where is the sign value or the y-coordinate equal to 0? I combine both your answers there. And where is the sign value equal to 1? And what's the last thing we do with the trig equation? Check it. And when you see 0 to 2 pi, it's kind of like, ah. Nothing negative, no negative coterminals. I don't need to think about anything. Let's just put them in order smallest to largest so that your marker of your exam is happy. And then boxing them makes the marker even more happy. That would be a 4-mark exam question. The first mark would come for swapping one of the identities for cos 2x. It doesn't matter which one. You get a mark for that. You get a mark getting down into the factoring. You get a mark for getting 0 pi and 2 pi. And the last mark comes from getting the pi over 2. We're done identities. We are done trig. There's not, no, there is a sine cos tan in unit 3. I lied. I was going to say there wasn't, but there is. Page 658, the exact questions are on the calendar.